Any other question? Any other question? Hey, why wouldn't so sit so far today? For assessment? Okay, also I post out what? The feedback link. Have you guys see the feedback link for Krav yet? Do you guys see that? Please provide some feedback. So the question will be, what are the question again? I'm not sure, have you guys seen it? Let me try. Maybe I brief you a little bit on the question so that you can put proper answer in. So this is the survey for you. So please fill it in. It will be very helpful whether we will be using it in future or not. Okay, so first you fill in which course you use it, and then there's some question here. So have you noticed an increase in the amount of the feedback you receive on your classwork since starting to use Krav? So this question wants you to compare the class with Krav and the class without Krav. Okay. Of course, this question have some bias, so it is better if you encounter a lecturer that not use Krav in one class but use Krav in the other class. Okay, because Krav has this feature that we can keep our comment. Okay, so if we can keep our comment, so we can reuse the comment. So it's easier to rewrite the comment. Otherwise, if we just mark by hand, we need to keep writing the same comment every time. Okay, so this is the question about that. So do you use Krav to access past assignment as your, okay, this one is quite straightforward. Yeah, this, have you noticed a higher level of direct detail feedback? Okay, whether it's detail or not. Okay, more better than the paper one, paper marking. Okay, and then how about the quality? Okay, better from Moodle or Teams? Whether it's better from Moodle or Teams or not. And then do you prefer grade digitally or by hand? And do you prefer it more than Moodle? Is it easier to submit than Moodle or not? Or is it easier to submit than Teams or not? Okay. So if you have a lot of no, right, you should have a lot of question answer to these two. Okay. You should have a lot of suggestion here. If you have a lot of no. Okay, so you suggest maybe submit in this way is better or the other way is better. Or yeah, additional feedback. Okay. Yeah. Try give them more feedback, then they will do better in their software. Okay. Yeah. So please fill it also by before next Wednesday, because they have a meeting. Okay. Yeah. Just spend some time and fill it. Okay. Yeah. Okay. A little bit hot today. Why you want to say something already? Not nothing. Okay. So lecture 6, what have we done last lecture? So we have defined what's let's recall what we did. So we define a vector field. Okay, vector field on, for example, let's see, on R2. So vector field on R2. What's a vector field? Eddie, what's a vector field? What's a vector field? Is it a number or a function or a set? Okay, so it's a function. Okay, so let's say it's a vector field on R2. So function, you need to tell me where's the domain and codomain. So it's a function from where to where, if it's a vector field on R2. R2 to R2, okay? So if it is a vector field on R2, then it is a function from R2 to R2. So if it is a vector field on R3, then it is a function on R3 to R3. So R2 to R2. So I give you a point in R2, you give me a vector in R2. Right. Okay. So make out a vector field. So what's the example of vector field last time we have? What's the example we have last time? We have the example fxy of minus yi plus xj. Okay. So I give you a point xy. Okay, you give me a vector. Or in other words, I can draw it like this in a column form minus yx. Okay. So what does this vector consist of? Anyone remember what's this diagram here? The example you guys worked out last time. So you send, well, you send what? You send 0, you send 1, 0 to 0, 1. Okay, so at 1, 0, you have 0, 1. Okay, let me plot this point. How about at 0, 1? What do you have? You have minus 1, 0. Okay, so minus 1, 0 is in which direction? Horizontal. Okay, minus 1, 0. And then similarly, you can work out what is minus 1, 0, which is just 0, minus 1, okay, going down. How about 0, minus 1? You get 1, 0. And so you get a vector 1, 0. So if you try all other points, you can see that this is a vector field rotating anti-clockwise. Rotating anti-clockwise. Rotating anti-clockwise. So if you put a particle on this plane, then this particle will flow with this direction. Okay, flow following the direction of vector field. Okay. All right. Okay. Okay. And then next, we talk about line integral. Okay, so next we talk about line integral. So what's the line integral? What's the line integral? Okay, so what's the idea of line integral? Sorry. The fence. Okay. Yeah, the fence or the curtain, right? So you have a function. Okay, you have a function at the top. Okay, but you want to integrate over a line. Okay, so what's above a line? Okay, what's above a line? So last time I say that because these curve, right, are the point in 3D space. So how you collect all these 3D space? Do you need to collect, okay, 2D in this case here. Okay, in this case is 2D. The domain is 2D. So how do you collect all these XY points? Can you find a way collecting this XY point? What's the way we use to collect all these XY points? Different XY. You remember? What's the way we use? For example, right? Okay. So for example, here, this one is x1, y1. Here, maybe x2, y2. So what's the convenient way to collect all these points? Okay, you use the parameter equation. Okay, I give you a time. Okay, you give me a time. I give you where the particle is. Okay, so use the parameter equation. So let's make it into the XY form. Okay, so let's say we have a parametric equation for C. So let C be a smooth plane curve defined by parametric equation. Okay, so I just need one variable to control my y and t. Then what happened to my integral? My integral can reduce to the integral of one variable. Okay, so do you know how to do integral on function of one variable? No. This is what you learn in calculus 1, right? Okay, so through the parametric equation, okay, you can turn this integral into integral of function of one variable. But what's the thing you need to compensate here? Anything you need to add in? What's the thing you need to compensate here? Is this, in other words, is this equation correct? No. Why? Huh? You need to take into account how this curve change. Okay, how this curve okay, how this curve change. So the factor here is remember the Pythagoras theorem. Okay, so it's similar to the Pythagoras theorem, but you are using x prime t and y prime t. And then take their square, take the sum. Okay, so for this part here, you account the length of this curve, and then this part here will tell you above each point, what's the weight? Okay, what's the weight above each point? Okay, so altogether, you will compute this fan here, or the fence, or the curtain. Make sense? Okay, so let's try one example. Okay, I'll let you work out this example. Give you about 5 minutes to start. Last time we worked out the example of half circle, right? Okay, so now we have this different example here. So what's this example here? You want to integrate a function 2x, okay, over a curve, but this curve is a piecewise curve. Piecewise curve. Okay, try and work out this integral here. So you need to find what's the line you need, okay, and then parameterize your line. You could discuss with your friend. Discuss with your friend. Discuss with your neighbor. Venus 韦泽 here now. 韦泽 okay. 当诗雨 not here. 顺林海人金波 yeah.
Sir, is aircon working now?
Not so cold yet.
So cool, right?
Yeah.
Yeah. I'll just take one picture and go.
Okay.
Sorry for disturb the class.
Yeah, no problem. Okay, thank you. T form. Anything? That one is working. Okay. Yeah, maybe some of them. Sure. Qi Feng 狗，外音狗，低胸狗，英奇，德一狗，雪燕，江城 not here，家业，李凯，袁家，恒硕，一鼎，玉伟 not here，燕博，恒业，林金，王林金，林金 not here，董洁，玉金，宜州 I think 宜州 here，定宇，柳晴，OK，曾诚，OK，硕宁，OK，鼓励，OK，燕，德轩，OK，莹莹，Grace，Grace，大雁，嘉文，秀，Michelle，OK，Michelle here，Ryan，永志，OK，雪梅，雪梅，OK。Okay, so what have you done? Have you tried and parameterized this curve or not? Okay, so how to parameterize the curve? What is C1? What is C1? What's this curve here? So this is given by a parabola y equals to x squared. Okay, so x is in terms of x. Okay, y is in terms of x squared. Okay, the range is from x from 0 to 1. Okay, so this is the C1 curve. How about C2 curve? How to describe C2y? Go on the spot. What is C2? This is a what line is this? In particular, it is vertical. Vertical. Okay, so vertical line, how to describe? Okay, good. So x is always equals to 1. Okay, y is going from where to where? Okay, 1 to 2. Okay, x is 0, y is 1, 0 to 2. Okay, good. Okay, so how to compute the integral here? So we can split our line integral into two parts. We didn't mention this property, right? We can do this integral similarly, we cut at the boundary. Okay, so let me write down for you. So if I want to integrate c of 2x dx, this is the same as integrate from c1 plus integrate for c2. Okay, where c is c1 plus c2 union c2. Okay, is this color okay or not? This color. Okay, I mean, color of the writing is okay. Yeah. Today got new people come in and why don't dare to say much. Okay. Okay. You want me to be your friend? You are today lah. Okay. Okay. So C1 and C2. Okay. On 2x dx. So let's compute one of them first. So what's the integral of C1 2x dx? Okay. So how do we write this in terms of integral of function of one variable? What's the variable you integrate over? X or y? X. Why? Because our C1 can be described just using X. Okay. So 2x dx become square root of x prime x square plus y prime x square dx. What's the range? What's the integration domain? 0 to 1. Okay, good. So in this case here, you need to compute what's the derivative of your x direction and y direction here. So let's go back and compute here. In x direction, you just get 1, okay, constant 1. But in the y direction, you got 2x. Okay, so there's a 2x factor coming in. So altogether here, what do you get? Integrate from 0 to 1, 2x of square root 1 plus 4x squared dx. Okay, so to do this integral here, you need to use the integration by substitution. So here you should use integration substitution. Okay, so you can let u equals to 1 plus 4x squared, and then du equals to 8x dx. Okay, and then do you want to try and compute this, or we skip this step here? Check later if you want. You can try and compute, and then the final answer you could get is 1/6 and 5 square root 5 minus 1. Okay. 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 Yeah, if you have problems seeing this integration by substitution later, we can continue if you want. Okay, how about the second line? How about this line here? How about this line? C2 is a horizontal or vertical line. Okay, it's a vertical line. Vertical line here, what's the weight on this vertical line? So this is a line from where to where? 1, 1 to 1, 2. And let's move it downward so that I can draw another dimension. 1, 1 and 1, 2. Okay, so this is the vertical line. So above this vertical line, what's the F? What's the F above this line? Our F is 2x. Okay, so what happened to the weight of this line? It's just 2. So it's a constant 2 function here. Okay. So if you want to compute the area under this curtain here, area of this curtain here, how do you compute? Huh? Just take the length by the width, okay, or length by the height. So it's just 1 times 2. So this is just equal to the area of rectangle with 2 minus 1 and height 2. Okay, which is 1 times 2. You could also go through the formula. Take the square root, take the derivative, and then you should see that you also get 2. Okay, but this is the more intuitive way to do it. Okay, but you also can try the formula. You want to try together, or you can try yourself? Do you get what I mean or not? You get what I mean? So you take this parametric equation, and then try and compute what is x prime, y prime, okay, and then compute this 2x. Yeah, any question? You want me to show you, or you know what I'm talking about? You know what I'm talking about? Question? Yeah. What's the function of y? Okay, what's the function of y? Okay, so I think it's a good question. So what's the function of y? So let me put C2 here. So what's the equation of y? What do you think? So no function. No function. So how? Change the parameter of y. So how to change the parameter of y? So let me try. Let me try. So here is 1. Okay, we know all the point on that line is 1 something. Okay, what's the thing? The question is, what's the thing? What's the thing? The thing is you cannot put x. This is what you know. So what do you put here? What do you put here? You change it to another variable, t, maybe. Okay, so we fix t from 1 to 2. Okay, so in this case here, we are doing dt instead of dx. Sense or not? Okay, so here, why am I talking here is, let me move this. So the parametric equation here is, let me use another color. X equals to 1, y equals to t, where t is going from 1 to 2. So now you differentiate with respect to t. Okay. So let me write the integral here in this case. So what is our integral here? So integral of c2 of dx. ds. Okay, so can you see that this x here is the length inside 2D. Okay, but inside 2D you have x and y direction. But through the parametric equation, you turn it into one variable because one variable can control the path. Let's say we can control it like that. Okay, these are nice paths that controlled by one variable. Okay or not? Okay, so let's see what's our C2 here. So let's bring my C2 down. So my C2 here is 1t, where, okay, so let me write here. So if you like, I put st also. Xt equals to 1, yt equals to t, where t is going from 1 to 2. So you need to check whether this curve gives you the right curve or not. You see, my time is going from 1 to 2, and my x is always 1. Okay, so does this give you the vertical line or not? Okay, so this gives you a vertical line. How about where you cut it? Where you cut the vertical line? So you cut the vertical line from t equals to 1 to 2. Okay. So one of the endpoint is 1, the other endpoint is 2. Making sense or not? Does it make sense? Okay. So what happened to my integral now? Okay. So my parameter I use here is t. Okay. So here become dt. Right? Okay. So integrate of my 2x evaluated on this curve, x is always 1. So I only got 2 times 1 here. How about the factor square root x prime t square plus y prime t square? Okay, so my range is from 1 to 2. Okay, so let me rewrite it. 2 times this. What is s prime t in this case? 0. Okay, you don't move in the x direction. How about y? You move in 1. Okay, with derivative 1. So altogether you get integrate 1 to 2 of 2 dt. So what's this? Huh? This is 2t evaluated from 1 to 2, which is 2. Okay, which is 2. Okay, same calculation. See? Is it okay? Same calculation. I mean, same answer, different calculation. Okay? Is that all right? Okay. I see you like yawn a few times. So tired. Okay. Yeah. All right. So, hey, okay. Any question about this yet first before we go to the next one? Any question or not? No? Okay. So far, okay. Okay. So the key point here is you turn a 2D line into function of into parametric curve, which is function of one variable. So you can integrate over one variable. Make sense? Okay. Parametric curve help you to describe the 2D curve into one variable using one variable. Okay. So next is a line integral with respect to xy. Okay. So let's say we don't integrate over the whole line. Okay, we just integrate over certain direction. Okay, either dx or dy. So what's the definition? So if we write integral of the curve, okay, of my function with respect to x, this is by definition what? Okay, this is by definition you cutting in the x direction. Right? You cut the secant in the x direction. Remember this notation here? You're taking the sum of secant and then taking limit to n to infinity, you introduce more and more secant to approximate the line. Okay, but now you only cut in the x direction. Get it? Okay, so you have some, so let me draw some curve. You have some curve and then you have some secant maybe. Okay, something like that. Okay, so you get more and more secant here, but now you only cut in the x direction, so you're cutting in this direction, something like that. And by theorem, how do you compute this? The left hand side, you just add an extra x prime t factor in. You just add an extra x prime t factor in. Okay. Right? Because why? Because originally what do you have? If you integrate over the whole curve, what do you have? You have the square root x prime t squared plus y prime t squared. So if you keep one of the variable constant, okay, then the derivative will become 0. Okay, square root of a square, you just get x prime t if you differentiate with respect to x. Y is just 0. Okay, so it makes sense, this formula here. Okay, so you only got x prime t if you integrate with respect to x. If you integrate with respect to y, then you get a y prime t. Okay, y changes, but x doesn't change. Okay, so let's do some example. Okay, do some example here. So let's evaluate this y squared in the x direction and integrate x with the y direction. Okay. So first is do on C1 first and then later do on C2. Okay. Do C1 first and then do on C2. So let's do C1 first. So let's do C1 first. So what is C1 in this case? So C1 is a line segment from -5, 3 to 0, 2. Okay, so this is the line segment. So you see, line segment. These points are different points with having different x and y. Okay, so how you collect this point into one parameter? Using a parametric equation. Okay, so how do you form this parametric equation? How do you form this parametric equation? How do you form this parametric equation? Any idea? So you need to put everything you learned before. Okay. So this is a line segment. Can you get an equation of line or not? How to get the equation of line? Huh? Equation of line. Right? Find gradient. Okay. So the formula is y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. Okay, so this one very important. So the right hand side here is the gradient. We call the m. Okay, so you got 2 points, right? So you can plug it in and find the line. So what's the line here? What's this line here? So you need to be careful. Why you need to be careful? Because this line have a direction here. So you need to start with -5, -3, and then end with 0, 2. Okay, so you need to be careful here. Okay. So what should we do? Let's solve this. Let's start with -5, -3. Make it a y1, y2. So what do I have? I have y plus 5 over x, sorry, y plus 3 over x plus 5 equals to 2 plus 5 over 0 plus 5. Is that right? Where, which one? 2 plus 3. 2 plus 3. Okay, correct. 2 plus 3. Okay. So y plus 3 equals to x plus 5. Is that correct? Is that correct? Correct. Y equals to x minus 2. So this is the line equation. Okay, so this is the line equation. Okay, parametric formula. Hmm? So how? You got what? You got x and y, right? Okay. So your x described by x, y described by x plus 2. Yeah. Okay. Does this work? So x going from where to where? What's the range of our x? From -5 to 0. Okay, so let's check. Let's check whether this gives the line we want or not. Okay. So when x equals to -5, what do we have? -5 and -3. Okay, which is this point here. How about at 0? We have 0 and 2. Okay, so the endpoint is 0 and 2. All right. So should we solve this? Let's solve this. So what's the integral here? Integrate from of C1 of y2 dx plus x plus dy. So integration is linear. Okay, so since it's linear, we can split this up. Similar to differentiation, integration is also linear. So we like linear stuff so that we can break out the sum and plus scalar multiplication. Okay. Okay. Yeah. Okay. So here, right, if you think that there's too many x here, right, actually we can rewrite this. Okay, for the sec, we don't confuse ourselves. So let's rewrite this. Okay, maybe use this color here. Let's rewrite this. Okay, so let's rewrite it into other variable. Let's say t and t plus 2. Okay, then we write t is 5. Because otherwise later I get you confused. Okay, let's rewrite it. Can you see that these two actually are the same? Same, right? Okay. Anyone not agree? Yeah, same. Are they the same or not? Same. This x here is just the coordinate, not the variable. So you need to differentiate between these two. Okay. Yeah. So yeah, usually, right? Usually this notation actually is not good. This notation here. This notation is not good because this is a function and then this is a variable. Okay. So you need to differentiate. So in future, if you want to avoid, just change this. Change the variable. Okay, so in this case here, we can use our formula. Over C1 of dx. So what's dx? We haven't computed dx yet. So let's compute, sorry, I doesn't mean cx, but I mean x prime t. So let's rewrite this function first. So integral over C1 of y squared dx, what happened? So we need to change it into dt. Okay, we change everything into dt because that is our parametric equation. Okay, we change everything into dt. So our y become t plus 2 squared. Okay, plus a factor x prime. X prime t. Okay, so what's the x prime t here? Okay, maybe let me write down the formula first so that you know what's going on. So here integrate from y in terms of t square times x prime t dt, okay, plus integral of c1 of x in terms of t and then y prime t dt. Okay, so you can see that from x coordinate we go to the time variable. From y coordinate we go to the time variable. Okay, it's okay. Yeah. So now we need to figure out what is x prime t and y prime t. So st is equals to t. This case here, y prime t is just 1. Okay. So if yt equals to t plus 2, y prime t here is also 1. Okay, so they are just 1. So in this case here, we need to integrate from -5 to 0 of t plus 2 squared dt plus also 0 from -5 from 0 of xt. What is xt? It's just t. Okay. So what's this integral here? We can quickly do this. So this is t squared plus 4t plus 4. Since both of them are integrated from -5 to 0, we can just add the integral out. So plus t. So altogether we have t squared plus 5t plus 4 dt. So altogether, what do we get? T cubed over 3 plus 5 over 2t squared plus 4t integrate from -5 to 0. So what's this number here? So 0 is always 0. Okay, so we need to compute what is -5. So minus of -5 cubed over 3 plus 5, sorry, minus 5 over 2 minus 5 squared minus 4 times minus 5. Okay, so what's this number here? What's this number here? Simple. What's this number here? Simple, still looking at calculator. What's this number? You do yeah, sure, you do separately. So I mean, it's not too hard. 125 over 2. 1, 2. Equals to minus 5 over 6. Yeah, correct. Okay, good. Very good. And we use a method that's different from the lecture note. Okay, lecture note, there's another kind of parameter I'll show you in the lecture notes later. Then you can compare between these two. Okay. Yeah, in the lecture notes, they figure out what's the direction vector, and then they form the line. Okay, the formula of line. So that the other method to get this line is line equals to point plus vt. V is the direction vector. I think we talked about this last time briefly when we introduced the vector function. Yeah. So yeah, that should work out. So mathematics is like this one. The wonder of the mathematics is you go different path, you still get the same answer. And you go different path, they still get the answer. Same answer. If it's different, then something wrong with the theory. Okay. Yeah. Any question? Why you get different answer? What? Oh, the answer can be negative, huh? Yeah, so this is the same question we encountered last time, right? So if it's negative, maybe the orientation is different or it is below the z equals 0. Okay, right? Or they cancel out. Okay, remember when we compute the volume cancel out top and bottom. Maybe you can try and graph this graph here. So what happened to this graph? So y square is always positive. Okay, y square is always positive. But x, what happened to x? X is depending on our segment. You see, our x is going from -5 to 0. So this gives the negative z value. Okay, so you can see that they are negative area. Correct? Yeah. Okay. Make sense? Sense? Okay. Yeah. So they will have some positive area, negative area, then you add them up together. Okay, so should we finish the next example or we take a break first? Are you tired? Haven't eaten breakfast. Take a break. Okay, let's take a break. Let's come back at 12:08. 12:08.首先，其他人呢？你们不是一起排？哦，OK，还有吗？有吗？有2个。啊，2个。
这个哦，对吧？你换一个 T 嘛，
对，
是容易来分辨嘛。
对，
假设如果不要换了，
不要换。
假设我不要换，
不要换。
这样我自己就不用再那个 X 牌标是。
你要换，你要写它是 S prime S 哦，就很乱的呀。
就会一个是一个是来控制的，这是什么？
OK，它有两层意思，就是对，意思说，如果你放 x 啊，假设你放 x 哦，这边我就要放 yx x prime x dx。OK，我现在怕的东西是他们会 confuse，那么你这边 dx，我这边又 dx，可是我这边又多了一些东西出来。
对，
但是
一个 x 跟另外一个 x 不一样。
不一样，这个 x 是指那个 x 的方向，这个 x 是指那个方向的 variable。
所以即使我不换，其实也是不一样，只要我分
不影响，只要你分辨得出就可以。但是不好啦，就是不好啦，不好就
反正还是一样啊。
当然一样，肯定一样嘛，因为你算 s prime x 的话也是拿到1嘛，然后你的这个 domain 也是一样，它只是一个 dummy variable 吧。
然后就只是来代替这个东西，然后我再带另外一个 add 进来，然后去换它。
可以这么说。但是问题就是我想说，就是这个 x 啊、是那个位置，这个 x 是一个control 的东西，它同时也是位置，所以我们才可以这样子写
哦，OK，
啊。但是我不想再写这个，是因为我怕等下他们看到 dx 又 dx，那么这个 dx 又多这样多东西出来了，这样就有点乱。其实那两个 x 都是同一个 x，就这样。可以听得懂，可以听得懂，
还行。
但你下一节可以教他们哦。
要啦，要我拿去跟李信跟 Bernice 比呢？傻的。
那个因为你是有2个公司 for line interview 嘛，本来上一个是 for ES，
OK，这呀，
上一个啦，他的意思就是我的那个整个 line function，
对，
然后它的 integral geometrically representation 就是你的 line 全部project 下来的那一个 area 对吧？就是这个，
对，
所以就是你的 line project 去 XY plane 的那个就是那个 area，所以这个是它的 geometric representation。下面这个呢，你要怎样理解它？
什么意思？
你因为你现在这个是 for DS 嘛，
对，
要想的修命就是这个不是，但是那个你的 line 每一个分就是这一些原理，这是无限个
对，
在这一个的话，
这个只有切 x direction，
对，然后你在这一个
这个图怎么看？
area 是怎样看
哦，你讲这个在算什么东西哈？
啊？
这在算什么哈？我讲一下啊，
因为这个我看不到
好的题目，这是一个蛮好的题目，你给我想一下。
对，它是整个东西
project 去 x，
explain 的，x axis
我很想讲，但是我这边写的不够清楚。对，我觉得是。
所以就是像如果我们用
比如说，OK，
这个的话
不用紧，就画在这边就可以了。OK，用在这边，不，用在这边，用这个，用这个。所以意思说呢，意思说什么呢？意思说，我觉得啦，如果没有错啦，但是我会去 confirm 一下，我下次再跟你们讲。我先跟你讲先。OK，如果是 dx 的话，它这条是它的 x 吗？这条是它的 x，或者希望啊，就是那个 x 啊，如果上面那条 x，所以呢，意思说呢，我把它我觉到这边，然后在这边切无限多，所以是看这边上面的 y square，可以吗
对
？OK，and then dy 呢？dy 就 y direction，意思说我
就去玩。
project 去 y，and then 我切，上面放 x 在上面。对，我觉得是这样，给我回去切一次，我觉得是这样。然后下一次 recall 的时候，我再讲这个东西。
因为
Yeah
这个你没有讲到他的那个样子，我就奇怪，蹦什么？就你刚才介绍这个时候，
这样我觉得蛮重要的，
算了，
我觉得蛮重要，
你这样，
我觉得蛮重要的，我觉得可以讲这个。OK，
考卷，
考卷里，哎，可惜已经出好了。
马上就会有一个人来帮他提高难度啊。
你下学期还教我们的
我下学期教不教你们？我下学期教什么？还没有定啊，还没有定。
老师是
一半是上面安排，一半是我们要求，然后开始怎么
教的抽象，
要教你们抽象啊？可以是可以啊，抽象代数可以啊，抽象代数很难，比这个好吗？Hello，
对，
可以啊，可以。带这么多朋友？没有，我觉得你们是这一个学期课太多，好像后几个学期都没有这么多，哎，4、5课吧。你们这学期有6啊？对啊，多一门课，多一门课你就多了上课时间，你又多了 project 时间啊，所以这个就翻倍啊。你看，如果你的课表后面9个。
结束了。
就是用一边要变更好。这里讲，我要定规定我我这个假如是我讲一个慢的功能，是讲过的，
presentation 看不上。
为什么不是？你不要 present，
不行。
你不想 present，你把分丢掉。你不重要。哦，你转了。哦，你要转了。哦，可以啊。如果你不做的话，哦，你就说你手工转。这样。不是啊，你要不要来听？
来听。
你再帮我看图片。2个人一块。没问题。那什么？
都意义了。
哦 ，OK。
然后再转
他转了，
我
你转去哪里？
觉得这个3年也可以自由就像我的3年。应该是报这个专业的，就是会有点不好的地方。
啊。 Okay, so let's start. Hello, hello, hello. Ready? 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 Are we ready? Are you ready yet?
Yeah.
Okay, so just now, so Ming Xiu asked about what's this geometric meaning here. Does anyone have any idea what the geometric meaning? Geometry meaning of this line integral with respect to a certain direction. What's the difference between this dx and split out the direction? When you split out the direction, what's the difference? So the construction in x here, right? So the construction in x here, what's the limit and sum construction here? So you cut your entire line into more and more interval. Okay, but what does this mean here? You only cut in the x direction or y direction, right? So what does this mean? You only cut in the x direction. Okay, so for example, just now we integrate along this C1, right? Okay, we integrate along this C1. Where's the x direction? Where's the x interval here? Where's the x interval? From where to where for C1? -5 to 0. Okay, so -5 to 0. So in this direction here, you cut infinitely many. Okay, and then you look at the weight. Okay, the weight here is the f xi star yi star within the interval. Okay, so it seems like a projection. Okay, you project your line, your curve to the x direction. Okay, and then you integrate over this, or you project your curve into the y direction, and then you integrate over it. Okay, but I will check the precise definition. I'll tell you next time, because Stewart doesn't have it. Yeah, what Stewart have is almost like this. So let me go and check it properly before I say more precise. Okay, so next time when the class start, oh, not next week, next Friday, next Wednesday, no class, not Friday. Okay, I'll tell you what's the geometry meaning. Okay, so you want to do C2 or we skip C2? You do it yourself, or you want to practice now? What do you think? Do you want to do it yourself or we do it together? Do it together? Okay, sure. Let's do it together. So let's do the C2 here. Okay. So let's say we want to integrate over C2. So what's nice here, he already give you the formula of this curve. So this is a curve defined by parabola equation, which is x equals to 4 minus y squared. Okay, 4 minus y squared. From the point -5 minus 3 to 0, 2. So let me copy this. Okay, let me copy it down here. So what is C2? So C2 is the arc of the parabola x equals to 4 minus y squared from -5 minus 3 to 0, 2. So what's this curve here? So let's draw out the curve. So the curve looks something like this. Okay. From -5 -3 to 0. Okay. So how to write this parametric equation here? Any idea? What's the parametric equation here? Let's write it in terms of t, okay? So what's the parametric equation here? So you're given the equation of this parabola already. So what does this equation tells you? X can be depend on y. So your x is depend on y. So what should you do? What can you do? Okay, you set y as a parameter. Okay, set y as a parameter t. Okay, then x is depend on t. How does it depend on t? 4 minus t squared. Okay, 4 minus t squared. So what's the range of t you need to take? T is going from where to where? Okay, the range of y is, in other words, the range of y is from -3 to 2. Okay, so from -3 to 2. So check, double check. So for sanity check, whether this give you the right point or not. Okay, the first point is when t equals to -3. So what's your x? 4 minus 9 is -4. -4 minus 3 is your starting point. Okay, how about your endpoint? Your endpoint is 4 minus 4, which is 0. Okay, and then y equal to 2, 0, 2. So this is your endpoint. Okay, so in the middle, it follows the shape of 4 minus t squared. Okay, following. Okay, all right. So now we want to do the integral on C2. Okay, so how to do integral on C2 here? Okay, how to do integral on C2? Similarly, we split the integral into two parts by linearity. Okay, linearity on function. So we need to re-express everything in terms of t now. Okay. So y squared become t squared. Okay. So on dx, what's the factor you need to add? Maybe I don't go to this step first. So let's go to, I want to insert my y as a function of t and then become dt with a condition x prime t. Okay, with an extra factor x prime t. Plus integrate over C2 times x with respect to t, what's the function of x in t, multiplied by y prime t dt. Okay, so you can see that this dx and dy become a function in x plus the extra factor x prime t. Does this look familiar to you or not? Look familiar or not? Change of variable. When you change variable, right, you need to do the chain rule. Okay, so the x prime t drop out, the y prime t drop out. Make sense? Make sense or not? So let me give you an example. So what example should I give? X equals to gt. Okay, x equals to gt. Dx equals to g prime t dt. So this is the similar thing. Make sense or not? Okay, make sense, yeah? Okay, so this is an example. Okay, so keep going. So so we change our integration domain from -2 to 2 for t. Y t squared is t squared. Y prime x prime t is what? Let's compute here. So what is x prime t? It's just -2t. Okay. y prime t is just 1. So we got minus 2t dt plus integrate from minus 3 to 2 of xt is what? 4 minus t squared times y prime t, which is 1. Okay, so integrate the whole thing. Yeah, let's get another one to compute this. No, another one. Okay. Can you try compute this? What do you get? Sorry? Over 6? 200? 245 over 6. Yeah. Yeah. Yeah, we get this. 245 over 6. Okay, so the actual question asks about the whole path, right? What's the actual question? Let's go back. The actual question, oh, okay, yeah, split into 2 parts, so never mind. Yeah. Okay, so what are we showing here? So note that there's a similarity between these two paths. What's the similarity? There's similarity between these two paths. What's the similarity here? Huh? The endpoint is the same, okay? But what happened to our value? One of them is negative, the other one is positive. They are different, okay? So this shows that the line integral actually depend on the path you take. Okay? So the line integral depend on the path you take. Yeah. And you can. Why do you want to do that? Okay, remember that when you do this, right, this is the area of the curtain, some curtain, area of some curtain. So it's like when you do the usual area, okay, I don't want to say area. So you could get negative value. Remember, integral you could get negative value. Depend on the orientation. If we don't look for the for example, the quantity of area, we don't need positive. We don't need positive, right? Because area is something positive, because only positive area makes sense, so we want positive. But in general, the integral could give you what it computes. What I mean, the integral may not mean anything. I mean, let's put it. The integral might give you the resultant area. I mean, difference of area. Okay, difference of area of positive and negative. Okay, because you split into the orientation. Yeah. Mm-hmm. Yeah, yeah, that's why. Yeah. Yes, that's what I'm trying to say. Yeah. You just follow what the integral give you. Because I don't ask for area, I also don't ask for volume or something like that. Right? Okay. So when the function is always positive, you integrate it, then you get the area. If not, then you get something difference of area. Okay. Yeah. Yeah. Only when you are asked for area, asked for volume, this kind of quantity, then need positive, because negative volume doesn't make sense, right? Negative area also doesn't make sense. But in general, the integral can compute any number for you. This question, not exactly. This is not the arc length. This is the weighted arc length. So you got some weight on the arc length. Yeah. Weight. Yeah. Yes. Yes, we attach magnitude to the, yes, correct, to the curve. Okay, there's you need to be careful when you talk about direction here. So there are two things here. Even with this line, right, I also can take different direction. Okay, so this is one of the direction. I think the direction you're mentioning is the magnitude, whether it's positive Z or negative Z. Okay, so there's another direction on this line. Later we'll talk about this. Why?
So dealing with the first view, the is positive.
Yes, the function is also.
Then if we get a negative integral, then this implies to do the opposite orientation. If something is positive, is
Okay, so first of all, positive function integrate over positive function give you the area. Okay, so if you found that where the function is negative, okay, so this means the graph go below z-axis, I mean z equals 0 plane. Then for that part, if you want to get the area, you need to take the absolute value. Yeah. Okay, but in total, if you compute like this, in total you get a negative. It might just means the difference of area. We do not know whether it is everything negative or not. Yeah. Okay. Oh, you mean that? Yeah. 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 Later we'll see this. Yeah. This orientation is the orientation of your domain, not the graph anymore. Yeah. This is the domain. Yeah. Okay, we will touch it now. Okay, let's go into this. Okay. Yeah, we'll talk about it now. So in general, okay, a given parameterization determine an orientation of a curve C, right? Because time only go into one direction. Okay, 0 to 1, 1 to 2, 3 to 4, something like that. Okay, only one direction. So this gives you an orientation. So we will call the initial point A and then terminal point B. And we will write negative C, okay, if the curve have the same point of C but in the opposite direction. Okay, so you can see this. So let's say this is our C from A to B. Minus C just means we start from the end point to the starting point. So what happened to our integral in this case here? So if you integrate the opposite orientation of curve, okay, is equal to the negative of the integral of the positive orientation. Okay. Okay. So if you change the orientation of the curve, it also give you a positive, negative changes of the original integral using the original orientation. Okay. Yeah. Okay. This is exactly the same. I mean, similar problem to Zhexian project. Okay, if you go the other side, although the area stay upright, but you still get negative values. Yeah. Have you done correction yet? If you've done a correction, later I will post it up. Then later everyone can see. Yeah, publish in our class journal.
all the corrections want to do easing the
Maybe. Yeah, maybe. Okay. Yeah. Yeah, the correction you can discuss with me first before you do. So don't go back and forward. And otherwise it out too much time. Just discuss with me once and then you fix it on. Okay. Okay. So we can extend this line integral into 3 space, n space, 4 space, 5 space, 6 space, any space until n space. Okay. So what's the difference? You just add the extra z prime t squared. Okay, so this is the Pythagoras theorem in the higher dimensional case. Correct or not? Okay. So there's a convenient way to write this. Okay, you don't write it all the way down, right? So you can write it in this compact form here. Okay, so if you can write your parameter equation using vector function, okay, then what's this extra condition here? What's the square root of sum of square? So this should bring you back to the linear algebra. Square of bunch of square. Square root of bunch of square. So what's this? This is a inner product. Okay, inner product. And then you take the length. So length of what? So these are all the derivative of our vector function. So you are taking the length of the tangent vector at each point. Okay, you are taking the tangent vector each. Okay, so this is the extra vector you bring in. And tangent vector. Maybe we skip this example because it's just similar. We add up one dimension. Okay, you can try this and then you can share. We can check the answer later. Okay, so these are just 3 dimension, 1 dimension out. Okay, next. So what does this line integral does? Okay, if you compute line integral of vector field, what does it does? Okay, what it do is it computes the work done. Okay, what's the work done in physics? W equals to Fx. Okay, so you need to apply force. If you apply force, but you don't get anything, that means you don't have work done. So if you use force, you must achieve something. Okay, non-zero distance. Only you will get the work done. Okay, you know how? Do you understand? You understand? Okay, so don't apply force in how to say what's the word? In how do you mean? What's the word? It start with F. The word. You do the work, but you don't get any result. F. What word? Anyone know? Filter? Filter. Yeah, filter. Okay. So you don't do a filter work. Okay. So some people, right, they work very hard, but they don't seem to get anything. Okay. There's no work done here. There's no work done. So you need to apply force with positive displacement. With negative displacement, then there's worse. Right. So with positive displacement, okay, work done. Then you get with the right direction of force, then you get the work done. Okay. So in our case here, our work done is not just F times X. So in the physics, right, you only got one direction. But now we have direction in 3D. Okay, in direction in 3D. So your force also have to apply in 3 dimension. So we split the force into 3 dimension here, I, J, K. And then it's a continuous force field. Okay. So we wish to compute the work done by the force in the moving particle along the smooth curve RT. Okay. So the problem here is the force is in 3 directions. The displacement is also in 3 directions. Okay, so how do we integrate 3 directions? Okay, how do we integrate 3 directions? Actually, we need to split into 3 directions. Okay, we just split the integral into 3 directions. dx, dy, and dz. Maybe we don't go into the derivation. Should we go into derivation? Maybe okay, let's show a little bit. Okay, maybe it's helpful for you to see why we compute like that. So the by definition, right? Okay, so this is the value we want to compute. So integrate the force, okay, this vector function with respect to vector. Okay, we integrate vector field with respect to vector function. Okay, let me write down. I don't confuse you. So this is a vector field. Okay, and then this is a vector function. Okay. So you say I only know how to integrate double integral or function of one variable, right? So how to integrate with direction? Okay, how to integrate with direction here? So we need to find some easier way. So let's say we can describe our vector function just with one t. Is it enough? Is it enough or not? Okay. So we can go to the next step. We already described our functions in one t using parametric equation. Is it enough? Okay. So we just need to compute the tangent vector of r prime t of FRT here. So what's the tangent vector here? So we replace it with another notation t. Okay, we write it as t. So this is just a notation replacement. But at the end here, this is the key part. After we do this, this integral split into dimension wise. Okay, split into dimension wise. So let's see why. So what's this inner product here? Okay, what's this inner product here? So F is a vector field. Okay, so you have a vector field. So you have a vector of function. Okay, vector of function. So how about R? How about dr here? How about dr here? So what is dr here? So dr here is x prime, y prime, z prime. Okay, so when you dot them together, they split out to sum. Okay, let's split out into sum. Is it okay? Yeah. Okay. Or maybe you want to ask a question, why I put dot product here? Why do I consider dot product here? F is a vector. dr is a change in vector direction. So how you put these two vectors together? What way you can use? You can use dot product of vector product, like cross product, right? Okay, so here we use dot product here. When you dot two vectors together, what do you get? When you dot two vectors, what do you get? No, I mean what value, what object you get? Yes, you get a number. Okay, so but this vector change with position, right? So that number also change with position. So when you integrate over a number that change with position, you also get a number. Okay? Because word down is a number. Word down is a number, right? Okay, so you get a number. Okay. 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 So for more derivation, right, you can study this. Okay. But the key here is you dot with the tangent vector here. Okay, tangent vector. Okay, let's look at some example. Let's look at some example. So find the work done by the force. Okay. So this is a vector field. Why is it a vector field? This is a vector field on what space? R2. Okay, R2. Because this is a function from R2 to R2. So it's a vector field on R2. In a moving particle along the outer circle. Okay, the circle is in the first quadrant, defined by cos ti sin ti. So this parametric equation should be very familiar to you, right? This describe what? Circle. Okay, circle, unit circle at the origin. Or center at the origin. Okay, but only 0 to pi over 2 because it only cover the first quadrant. Okay, so we want to find this work done. So work done is formula is what? So we integrate over the curve, okay, and then f of dr. Okay, f of dr, the direction. Okay. So by definition, what is this? There are a few ways to do this actually. Which way we want to try? Let's try the final answer first. What's the final answer? So the final thing you use is integrate f1 dx plus integrate f2 dy. This is the final form we have just now. Okay, over C also, over C. So maybe we try two ways. We try two ways. Okay, we try the original way and we'll try this result. This main result. Okay, let's try this. So C is what? C already given. Okay, C is from okay, let me wait right here. So C is given already. C is this quarter circle. Okay, call it quarter circle. For t going from 0 to 2. Okay, so this is our C. So if we want to integrate with respect to x, what do I have? So f1 is x2. Let's write it down first. And then f2 is minus xy. So minus xy. Okay, so this is it. So we have C, we have C. So remember how we compute this just now? In line integral with respect to dx, line integral with respect to y. Okay, how do we compute this just now? We need to have the parametric equation first. Okay, for xt and yt. So what's your xt and yt? Can you freely translate between the language of parametric curve or not? What is xt and yt here? Xt is cos t, yt is sin t. Okay, good. So our t is going from 0 to pi over 2. Okay. So what else? What ingredient do we need? Because this line is not straight, right? Okay, so we need to have an extra factor of x prime t and y prime t. So x prime t is what? X prime t is minus sin t. Y prime t is, so in the first case here, c is from 0 to pi over 2. X squared is cos square t, okay, with a factor of minus sin t dx. Okay. And then integrate from 0 to pi over 2 again of x, which is cos t, y is sin t, and then y prime t is cos t. Oh, sorry, dt. Yeah, correct. Thank you. So we changed to t already, so everything should be in t. Okay, good. Okay, so altogether we have integrate from 0 to pi over 2 minus 2. 2 copy, right? Okay, minus 2 of cos square t. So how to do this? So I think this is the integration by substitution. Okay, good. So if I want to do substitution, I get u equals to cos square t. Wait, so no, my substitution is u equals to cos t. Okay, and then v is equals to minus sin t. Okay, so what happened to my integral? So my integral become, sorry, this is dv of dt. So my integral becomes u squared minus of dt, correct? Okay, so sorry, I go a bit further. So let me write out first. So integrate of cos square t sin t dt equals to minus u squared dt, correct? du, my du. Okay, du, correct. Be confused with integration by part. Du, like this. Okay. negative cancel out. You mean? Yeah. Sure. I was wondering, can I straight away change my u back to cos t? Cannot. Can? Oh, cannot, right? Okay, cannot, then never mind. Okay. Then this means I need to change my integration domain then. When t equals to 0, what happened to my u? My u becomes 1. When t equals to pi over 2, what happened to my u? 0. Okay, so I get, so minus minus, I get positive, so 2 times 1 to 0 of u squared. Correct? Right? Okay, then keep going. So u cube over 3 over from 1 to 0. And then you get, what do you get? Minus 2 over 3. Yeah, minus 2 over 3. Yeah, question? Where? Which one? This one? This one? Ah, okay. Okay, any other question? So how about we try another way? We try the traditional way. Okay, what do I mean by traditional way? So we start with the definition. Okay, we start with the half of the definition. So the half derived one. So the second way. Okay, so what's the second way do I mean? Okay, let me write it out. Okay, so the second way we have is, remember this is by definition what? If I substitute my f with my curve, okay, and then I dot with my tangent vector. Okay, how do I write my tangent vector? R prime t dt. Okay, let's try this method here. This is the previous step. Okay, so we should see that this is the same as we split it up. So what do I mean by this? What is my f? So let's bring my f down first. Fxy equals to x squared j. Okay, if you like, you can write it as a row or column. Okay, easier for you. How about my r prime t? Okay, what is the rt first? So my rt in the row form is a cos t and sin t. So r prime t is just minus sin t cos t. Okay, not that. We are doing the same thing. We're just using different presentation. Okay, just now we do it separately. Now we do it together. Okay, so it's really the same thing, but we just put it as a different notation. So what do I get here? So this t here, remember what's the range? From 0 to pi over 2. Okay, so you need to integrate from 0 to pi over 2. Ft is just what? Cos squared t comma minus cos t sin t. Okay, and then you need to dot with this vector here. Wait, let me okay. You need to dot with the tangent vector minus sin t comma cos t dt. Okay, so what's this dot product? What's this dot product here? Cos square t minus sin t plus minus cos t sine t, cos t, dt. Okay. So can you see that this is what we did just now? F1y and ft(y). Can you see it? Can you see this is what we did just now? This two. Okay. Yeah. So yeah. So you can start with any method you like. But for the inner product one, right? Later when you do surface integral, that one will become more apparent. Okay. More apparent. Later we will need to use dot product in the surface integral. Yeah. Where? Graph again. The integration domain only depend on your curve, doesn't depend on your field. Doesn't depend. Okay, when you do this integration, right, this is only depend on the C, doesn't depend on the F. This, you mean this direction or this direction? Which direction? Oh, the red color one. Okay, so if you do it negative, you mean if you go it instead of going from 10 to 01, you go from 01 to 10. Okay, so this is just now we already gave this condition here. If you take the negative orientation, okay, it's just the negative of the original orientation. So that means you will get, just now we get negative 2/3, then that means you get 2/3 if you change the orientation. Go 2 to 0. Uh-huh. Yeah. Yes. 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 So you see, the problem changed into the one variable case, right? If you swap the integration domain for, so integrate from A to B is the negative of integration from B to A. This is the same, but we do it in a 3D manner. You know? You get what I mean? We just do it in a 3D manner. It's the same from the calculus one. Because calculus one only have one direction. Right? A to B or B to A. That's only the two things you can do. No, depend on what you want to compute. So if the question already give you, I want this direction, then you compute this direction. Why do you want to go and do the other direction and then take a negative of it again? Why do you want to do extra work? You get what I mean? Unless you know the other direction and then you want to get this direction, then you take a negative. If not, the question asks you to do this, then you do this. Unless the other one is easier to compute. If not, don't do double work. You get what I mean? Yeah, the domain is important. Yeah, the domain is very important. Throughout this integral chapter, right, domain change, how to find domain, how to build parametric curve is very important. Okay. Yeah, domain is really important. If you can solve the domain, basically you can solve half the question already. The next part is just integrate the function. Any other question before we take a break? So the next example, we just left it as exercise and then we will start other stuff next time. Okay, and then we'll do line integral, do surface integral, do green theory, do divergence, do curl, divergence theorem, and then finish for the semester. Okay. Yeah. think we got 1, 2, 3 more classes to go. 6, 7. Yeah. Hopefully we can finish on time. Okay. All right. So see you next week, next Wednesday, 1 o'clock. So I got 2 timekeeper. So Yan Jing and Yu Jing will help me to keep the time. Next week.
So I can back up with them.
Pack up for what?
3 minutes.
Don't need pack up lah.
Not too much problem, just delay.
Oh, yeah.
Slight delay. Huh?
如果
因为有些人抓就在那边。
有没有人可以提问？
没人提问，我会问啊。我当然会问啊。
所以去单里面的时候，你抽个 link 吗？
啊，要，我已经 download 好那个 app 了。
哦，那个。
现在好用吗？
在房间。
等下我声音关掉。我再去借2把麦来，一人1把麦。不用啦，I mean 就1把给你们，1把给观众，1把我的。那1把给观众啊，1把。
所以
没有，你要问问题，我给你问问题啊。Yeah。